The reason the universe was created is not yet clear, but it began about 13.75 billion years ago. About 380,000 years after the Big Bang, space cooled enough for atoms to form, marking a major turning point in cosmic history. Before that, the universe was a hot, dense soup of charged particles that was opaque to light, making it appear like a bright star. A different theory suggests that the universe may have existed before the Big Bang. This idea is supported by physicist Brian Cox, who argues that while the Big Bang is believed to have marked the birth of the universe, modern cosmology suggests a phase of inflation before the Big Bang. During this phase, the universe repeatedly doubled in size due to exponential acceleration, causing the universe to become larger than the entire observable universe in less than a second. If everything started out smaller than an atom, then this rapid expansion created all known matter, including the particles that make up everything we see in the sky. Despite its fantastical sound, this hypothesis is now a mainstream concept in cosmology. But important questions remain. What caused inflation? What stopped it? How long has it been? The number of worlds could be infinite, according to speculation. If true, it would imply that fundamental laws of nature, such as the speed of light and the strength of gravity, could be different in different universes, raising the question of why our universe is so conducive to life. One hypothetical answer is that we naturally exist in a universe that supports life, assuming that every possible combination of natural laws exists in other universes. The concept of conformal cyclic cosmology, CCC, proposed by physicist Roger Penrose, suggests that our universe is part of an endless cycle of creation and destruction. Penrose's theory suggests that there may have been a world before ours that began with a Big Bang-like event. The recent discovery of galaxies and black holes by the James Webb Space Telescope supports the CCC and casts doubt on the date of the Big Bang. Some speculate that information from previous worlds may have been transmitted to ours, as evidenced by the formation of a massive black hole hundreds of millions of years after the Big Bang. According to Penrose's hypothesis, the end of a universe is analogous to the beginning of a new universe, where the black hole consumes all matter and reaches equilibrium before a new universe is formed, continuing the cycle. This idea is consistent with the theory of inflation proposed by physicists Andre Linde and Alan Guth, who argue that inflation may never stop completely, potentially leading to the formation of bubble universes and multiverses. Inflation explains why the universe appears so uniform, because it smooths out the early cosmic collisions. The theory of eternal inflation suggests that while inflation may stop in some places, it continues elsewhere, creating new worlds over time. This ongoing process gives rise to the fascinating concept of a multiverse, a space in which the universe is constantly evolving without a clear beginning or end. Astrophysicist Neil deGrasse Tyson offers an interesting perspective, arguing that while we are part of the universe itself is actually inside us. Answers to fundamental questions about our existence, such as where the universe began, who and what created it, and whether we are a product of chance or part of a greater plan, are coming soon. Tyson's claim that the James Webb Space Telescope has found evidence of black holes in the past supports this idea. If true, it would mean that our universe is just one of countless rebirths of the universe, and that the entire history of cosmology needs to be reassessed. The James Webb Space Telescope challenges our understanding of what defines the universe, especially the cosmic destroyer galaxies. Some galaxies appear to have formed shortly after the Big Bang, and thus may be older than the universe itself, raising questions about the inconsistencies in our current knowledge. The ages and distances of about 20 of these galaxies have been confirmed by independent scientific teams, and further calculations are underway to determine other candidates that could potentially be home to massive black holes instead of galaxies. One confirmed black hole could be 1 billion times the mass of the Sun, but it formed just 500 million years after the Big Bang. Considering that only the first stars at that time should have done so, it begs the question of how they could have accumulated so much mass so quickly. Researchers are looking for new explanations for these results, which come from recalculating the age of the universe and the origin of matter. Quantum physicists propose that nothing really exists, and that nothing could have existed before the Big Bang. It is believed that the state before the Big Bang was a perfect equilibrium of forces, with quantum fluctuations canceling each other out. Then, a tiny, previously unknown trigger point upsets this balance, causing an explosion and the birth of something new. The information and fundamental structure of everything observed in the universe is contained in this single hot medium. This environment of quarks and gluons, known as quark-gluon plasma, was created in a fraction of a second by the Big Bang. About a millionth of a second after the Big Bang, space cooled and expanded, and subatomic particles began to form through a series of phase transitions. The Hadron epoch marks the beginning of matter, with the formation of protons and neutrons, while the Lepton epoch sees the creation of electrons. About 380,000 years after the Big Bang, the universe cooled enough for protons and electrons to form stable hydrogen atoms, allowing light to travel more freely through space. Today, the cosmic background radiation serves as a record of these early cosmic events, potentially providing important information pointing to other universes. Revolutionary discoveries by the James Webb Space Telescope provide insight into the Big Bang and its subsequent expansion. Tyson's theory of black holes in the previous universe is gaining traction, suggesting that our universe may actually be part of a cyclical process. After the initial expansion, the components of matter were evenly distributed and gradually coalesced under the influence of gravity to form the first stars. The telescope revealed highly evolved galaxies at the time, suggesting an age of hundreds of millions to billions of years, while previous estimates put the universe's age at 500 million to 1 billion years. This discovery raises the possibility that a second universe exists. The concept of a cyclical universe, once considered unrealistic, was revived by Roger Penrose in a widely acclaimed book in 2010. His proposal shocked his scientific colleagues, who compared it to the application of Eastern principles of reincarnation to the universe. But Penrose, one of the most prominent astrophysicists of our time, is a respected voice in the field. Following the death of his close friend and colleague Stephen Hawking, Penrose received even more recognition, winning the 2020 Nobel Prize and being knighted by the Queen. This honor reflects his outstanding contribution to physics and his commitment to making science accessible to all. Penrose wrote numerous books to help the public understand complex astrophysical concepts, appeared on various BBC science programs, and contributed to educational shows for children and young people. His claims have been taken seriously, especially since he published a scientific report showing that the cosmic microwave background radiation, which has remained unchanged since ancient times, shows signs of black holes that may have existed before the Big Bang.